Welcome to What's New in Outer Aerospace, and I'm Michael Neufeld, the curator in the Air and Space Museum, and I'd like to welcome today Alan Stern, who is the principal investigator of the New Horizons mission to Pluto. I think we should start just by congratulating him and his team for the fabulous achievement of flying by Pluto and starting to send back data. Thank you. Before I just say the introduction, I'll just mention a couple things. This is, we have Q&A at the end, so if you want to come up and ask a question, please see Marty there in the blue shirt. We will take online questions, so go to airandspace.si.edu. If you were watching the online, of course, you'll already see that on your screen fairly soon. So you can send questions out, send questions to us to be asked later in the Q&A session. And I wanted to thank Boeing, who is the sponsor of the What's New Aerospace series, for their support for this program. So let me just start off by saying that Alan Stern is, of course, the principal investigator of the New Horizons mission, which successfully flew by Pluto and its moons on July the 14th. And has sent back a trove of new data and will be sending back, as he will tell you, data for a long time to come. So we're going to keep seeing new stuff coming out in the future. Alan is first and foremost a planetary scientist with a specialization in the outer planets, in the Kuiper belt, in comets and icy bodies. But he is an associate vice president at the Southwest Research Institute in Boulder, Colorado, and among his many other things he's doing, he's an entrepreneur. He's involved with many startup companies. He's involved with promoting commercial space flight and the suborbital tourism and research flights that are coming. But of course, we have him here today, above all, because he led the team that created the New Horizons spacecraft that sent it on its way and successfully carried out its mission. So thank you very much, Alan.
Well, thank you, Michael.
So we have a presentation that'll probably take about half an hour or so. But, go ahead.
Shall I start?
Yes, thank you.
Okay, thank you, Michael. So thank you for coming. I thought I'd start with a question for you, because you'll probably have questions for me later. How many of you here, show of hands, have heard of New Horizons and our Pluto flyby? Oh, that's a relief. Good, great. Well, this is something that I'm very proud of, but I want to say as the principal investigator and the leader of the project that it's really a team effort. 2,500 Americans worked to build and launch New Horizons, and a much smaller team, numbering only a few dozen, flew it across the entirety of our solar system to make the historic flyby of this most distant target ever explored 10 weeks ago today. We have a few members of the team who are here. They're seated back over there. If you could stand up, and if I could ask for a round of applause. Okay, well, if you look at the screens now, my first slide is up, and it's got the title of the presentation, and it's very simple. We did it! We started off sort of against all odds 25 years ago, after the Voyager project had completed its last flyby of Neptune. And it wasn't possible for Voyager to go to Pluto at that point. So some of us in the planetary science community started working to get a mission to Pluto. It took 14 years to figure that out and to get that approved. And then it took 4 years to build the spacecraft and get it tested and ready for launch. And then it took 9.5 years to fly it across the solar system. So you got to really want it in something like this. You got to be happy with delayed gratification. And it's really great to be able to put it in past tense and say, we did it. We did, and it was a flawless flyby and connected with a lot of people, a lot of different ways. Today, I have a chance to tell you about the project just a little bit and about Pluto and its system of moons quite a bit more. So if I can, well, I think I can do these myself. Forgotten. Got this handy dandy clicker. If it clicks. Let's see. There. Oh, there we go. That's the best picture of Pluto ever made before New Horizons. I thought I would start with that to put things in context. Kind of smudgy. Now this is made with the best, the biggest, the baddest gun that we have for a telescope, the Hubble Space Telescope in Earth orbit. But Pluto is so far away, 3 billion miles, that the best we could do is come up with this lousy picture. And I can call it lousy because I was the PI of the project that took this image. And I've been a part of writing scientific papers that interpreted this image. There's not much you can really say about it, is there? If that was a picture of the Earth at that resolution, you wouldn't be able to pick out North America. But we did it. And look at that. That's the New York Times, the morning after our flyby on the left side, July 15th, 2015. Look at the increase in resolution. We're looking at an area on Pluto about 250 miles across, and that image is actually the discovery of mountains on the surface of Pluto. And what I really like about this particular slide is that there's another New York Times cover on the right. It's the first image of Mars made by the first flyby of Mars, which took place 50 years ago, 50 years from that date exactly. On the left, it says late edition, 15 July 2015. And on the right, it says late edition, 15 July 1965. In that span of time, in essentially one career, one long career, the United States was first to every planet in the solar system, beginning with the innermost planets, Venus and Mars, and then expanding out to Mercury and Jupiter, and then Saturn, Uranus, and Neptune, and finally Pluto. This country has led the entire exploration of the solar system. Others participate more and more. The European Space Agency, the Russian Space Agency, even lately we've seen plans announced by countries in the Middle East and countries like Japan and Korea to explore the planets with robotic spacecraft. But it's your country that has led this entire historic era. And New Horizons was the capstone to the initial reconnaissance of the planets. And it's great being able to run the anchor leg in that relay, you know, and we're very proud of the fact that we could do that on New Horizons. Well, let me tell you a little more about it. Oops, I'm gonna start with our spacecraft. So there's a cartoon drawing of our wonderful little spacecraft called New Horizons right there, and in the inset is an actual image of it on the clean room floor down at the Cape before we launched it. There are a couple of people there for scale. The spacecraft is about the size of a baby grand piano. And miniaturizing the spacecraft was very important because it allowed us to get the most speed out of the rocket by having a very small spacecraft. So because it's light, we could fly it faster. And that was the key to our setting a record for crossing the solar system in only 9.5 years. But I also want to say that on board that little spacecraft that only weighed 1,000 pounds when we launched it, full of fuel, now about half that fuel is gone, so it's a little lighter. There's 7 scientific instruments that are the most powerful suite of scientific instruments ever brought to bear on the first reconnaissance of a planet. And, you know, a lot of the reason for that is because the last time we launched something, Voyager, to do its historic exploration of the giant planets, they were using 1970s technology for the scientific instruments in the spacecraft, and we had the advantage of 2000s era technology. So whereas, for example, the ultraviolet spectrometer on Voyager had 2 pixels, our ultraviolet spectrometer had 32,000 pixels. So we could map 16,000 times faster, take data that much faster. It's amazing, the capability on board these instruments. The Ralph instrument, which contains an infrared composition mapping spectrometer, replaced a 1-pixel device on Voyager with 64,000 pixels. Okay? And what's most amazing to me is the level of miniaturization. Not only do we pack a lot more firepower into this payload, but all 7 instruments on New Horizons, all the cameras, all the spectrometers, the plasma instruments, the radio science, throw in the student dust counter, all of them combined weigh less than just one instrument, the camera on the Cassini-Saturn orbiter. And if you turn them all on at once and measure their power draw, the combined power draw from all 7 instruments and their microprocessors, added all up, is 28 watts, about a half a light bulb. Some of the instruments only draw 2 watts. It's really an amazing accomplishment. that they pack so much firepower, so much capability, and yet we could miniaturize it to this extent. So what were the mission objectives? Well, we actually have a long list from NASA that we had to meet. The top objectives form a triad, the three most important things to do, and it says it right there: to map the surface of Pluto and its moons, to map their surface compositions, put spectra on every pixel, and to determine the composition and structure and escape rate of Pluto's atmosphere, which we discovered back in the 1980s from the Earth. Now, you remember that fuzzy little dot picture from the Hubble where you can't even see what's what on the surface at all? We brought a capability to map not just at geological resolution, but at super resolution. The very best images of Pluto that we will return from the spacecraft have a resolution equivalent to that inset, the little blow up right there, where you should recognize New York City. And let's talk about the details that those best images could determine. So if New Horizons had flown over the Earth, over New York City, at the same altitude that it actually flew over Pluto and looked down, that is what you would see. Now, on these projectors, you don't see the full detail. If you put them on a computer screen, you could see more, but I think anyone can pick out Manhattan Island there with the Hudson on the left and the East River on the right. And inside Manhattan, you can probably see that green rectangle. That's Central Park. And if you look closely, you can see dots in Central Park. Those are the ponds in Central Park. And at least on a computer screen, if you look closely on the left side of Manhattan, along the Hudson, you can count the wharfs on the Hudson. In that image, you can count the runways at LaGuardia. Now, we don't expect to find any of those things in our imagery of Pluto, but it gives you a feeling for the level of detail. We're going from a situation where we couldn't even find the largest features on the surface to being able to essentially pick out buildings and ponds and wharfs or equivalent scale. So we're bringing a lot of firepower, as I said. And people loved it. People really connected with New Horizons. This is a picture at the Johns Hopkins Applied Physics Lab where our mission control is, just 45 minutes or an hour north of here, on flyby day. And you can see the emotion that was in the room. And if you watch some of this on the web or on television or NASA TV, I know you felt it too. And even if you missed that, you've probably read about it on the web or in a physical magazine and seen the way that people connect. So I'm really happy with that because I think it really shows that people dig exploration, that they really like it. And you know, nothing like this had happened in a long time. The Voyager project concluded its last flyby in 1989, a generation ago. So for about half the people in America, they'd never seen anything like this. They either weren't born or they were too young to remember Voyager. And we set all kinds of records for social participation. I'll talk a little bit more about that later. But first, I want to show you this little video. This is an animated GIF made over a few weeks from onboard New Horizons of us flying up to Pluto. And you can also see its very large moon, Charon, which is about the size of Texas, orbiting Pluto. Look at that. So we start far away, tens of millions of miles away, back at the end of May. And then throughout June, it's getting bigger and bigger in the window. And into the end of this sequence in early July, wow. That's what it's like to ride aboard New Horizons, traveling 750,000 miles a day, turning a point of light into a planet before our very eyes. This picture is a sort of family portrait. You may know Pluto has 5 moons. Charon, the one the size of Texas, is the largest, and then 4 much smaller moons. Of those 4, 2 are pictured. I put a box around them so you wouldn't think they were just little specks on the image. They're much smaller. This is Styx and Hydra, and they're actually the 2 middle-sized moons of Pluto. They're each about the size of metropolitan Washington, D.C. So they just look like dots in that image. The 2 very smallest moons, Styx and Kerberos, aren't even in the image. And I won't show you anything about them because all the images of Styx and Kerberos are still up on the bird, up on the spacecraft. But I can show you more about the satellites right now. These are close-ups on the left of Styx and the right of Hydra. Again, about the size of the Washington Beltway. They're both very similarly sized. You might think to yourself, well, Styx looks a lot more colorful. That's because we have color images of Styx on the ground. Hydra on the right, we only have what we call panchromatic or black and white images. So don't let that fool you. But they're both interesting even at these scales, which are not the best resolution that we will eventually have when we've sent all the data to the ground. But on Nix, you can see that big crater in the middle with something red that looks like it's splashed out. Later, we'll have compositional information to tell us what that's made of. We don't have it yet. On Hydra, you can see that it's distinctly angular and has prominent features, craters on the surface. We're going to know a lot more about both of these when we get the rest of the high-resolution imaging. When we get compositional measurements, we'll have temperature measurements on Nix, not on Hydra, because it was at larger range from the spacecraft, and some other data sets as well. So we're going to revolutionize our knowledge of these two, and Styx and Kerberos weren't left out. We just don't have the data yet. But this is the big moon. This is Charon. So from the left side to the right side of that world is about as far as from El Paso to the Louisiana border. If you've ever driven across Texas, you know that's a pretty long way. It's 1,200 kilometers or 750 miles. It's huge. And I think Charon turned out to be a lot more complex and interesting than we expected. It's clearly had a very active geology over time. You can see running across the center of the image, left to right, is an enormous chasm, a canyon that makes the Grand Canyon look like a pinprick by comparison. That canyon runs over 1,000 kilometers. It's miles deep. It's about 100 miles wide. You can also see lots of splashy, bright ejecta rays from craters. And those craters are going to allow us to do something very interesting. They're going to allow us to do actually two things. One, by counting how many craters are in different parts of Charon, we can compare the ages of different surface units, because the impactors are raining down constantly with time, so places with more craters are older. They've accumulated more craters. Just like if you take a sheet of paper out in the rain and you count the number of dots, and you have one piece of paper that's been out in the rain a while, one that's just been recently brought out, it'll have less dots on it. Same idea. But the other thing that we'll learn from those craters is something about the sizes of the impactors. It'll let us probe the population distribution of the smallest things in the Kuiper belt, so small that we can't see them from the Earth or our best telescopes. So this is kind of a witness plate that will allow us to uncover new things about the Kuiper belt in which Pluto orbits. Now, if you look even more closely, and I'll try to show you an example, some of these craters, and I'll show it on both sides, some of them don't have bright, splashy ejecta deposits. They actually have dark ejecta deposits. And so that's an interesting thing we didn't expect. Why are some of them apparently excavating bright material and others excavating dark material? Well, it could be that the impactors themselves contaminated some of these and made them dark or bright. But it might also be that we're learning that Charon's interior is spatially inhomogeneous, that some places have dark material below the surface, and that's what splashes up, and other places, bright material. We don't know. And maybe it's a third possibility. Haven't thought about that yet. But we're seeing a lot of complexity we didn't expect. And another example of that is if you look at the North Pole of Charon, you'll notice it's very dark. The opposite of Pluto, in fact, which has a bright polar cap. This is sort of a dark stain stretching over an area of actually several hundred miles. And we're not sure what caused it. One theory is that some of Pluto's atmosphere may have actually accreted onto Charon's surface, where it was radiation processed and turned into this dark stain, which is actually quite red and is the color of what you get when you take the materials in Pluto's atmosphere, methane and nitrogen and carbon monoxide, condense them in a laboratory and shine the same radiation that the sun is sending to Charon. It turns just that color. Now soon we'll have spectra, which will give us a much more detailed set of constraints on the composition. And we'll try to really fingerprint this. It's very early days. 90% of the data from New Horizons is still on the spacecraft, and we're just identifying the easy pickings in the first data sets that have come to the ground. I like to make the analogy that if you were touring a house for the first time, a house you might be your friend's house, or maybe you're looking for a new house, and you'd only gone in the entryway, and you'd only seen about 10% of the house. You didn't know what the other rooms contained. That's the situation we're in these early days, because one of the things that we designed into New Horizons to keep the cost down was a telecommunications system that's saved us a lot of money by reducing the size of the antenna and the power of the transmitters. And so it's going to take us about a year to get all the data to the ground, and so far we only have about 10% of it. A lot more to come. And yet, even though we only have 10%, we're learning a lot. Now, this is Pluto, and I'm sure many of you have seen it before with Pluto's famous heart-shaped feature that we informally call Tombaugh Regio, to honor Clyde Tombaugh, who discovered Pluto in 1930. Pluto's about twice the size of its big moon, Charon. It's about 2,400 kilometers, or a little over 1,500 miles across. So from limb to limb is about the distance from San Francisco to New York. And the circumference, if you were to drive around Pluto's equator, is about the distance from Manhattan all the way west across the United States, across the Pacific Ocean to Maui in Hawaii. So that gives you a feel for how large a world this is. Now, I really like this image. It's an exaggerated color image to bring out the details, to show you that Pluto's surface is very different from place to place, not only geologically, but you can see the northern regions at the top where the polar cap is, have much bluer ices than other parts of the planet, that the heart-shaped feature that we call Tombaugh Regio itself has different units. The one on the right is bluer, the one on the left is redder. The big dark regions down below, actually running along the equator, are a little bit like lunar mare. They're very red, and they seem to be devoid of some volatiles. We're going to know a lot more soon because compositional data just landed over the past few days. And so we're going to start to map Pluto's composition from place to place. We also have a lot more detail than you can see in just that one hemispheric image, despite how pretty it is. And that inset that blows up just one little place on the planet is just a taste of that. What I'm going to show you next are a variety of places around Pluto and some of the highlights of what we're finding. So this is the image that was on the cover of the New York Times on July the 15th. It's the discovery of mountains on the surface of Pluto. Now, we wondered for a long time if we would find mountains, and here's why. When we take compositional spectra of Pluto from the ground or from the Hubble, we see that the surface is covered in nitrogen ice. Now, nitrogen turns out to be a very weak material. It doesn't bond very well, and it's not strong, so you actually can't build mountains out of it, or any steep topography. If you pile nitrogen up, it slumps under its own weight, even in Pluto's weak gravity. So as we were approaching Pluto, the science team knew that if we discovered strong topography like mountain ranges, that we would know that the nitrogen layer is probably not very deep, wherever we saw mountains at least, and that there must be something much stronger like water ice or rock that's supporting that topography. Well, guess what? That's exactly what we found. Those mountains are huge. They're as tall as the Rockies. Who thought of that? Who would have thought of that before we got there? And you can see from the scale that we're looking at a field about the size of western Colorado. So this is very much the Rocky Mountains on Pluto. Now, this is another place called Sputnik Planum, and that's the informal name that we've given it to honor the very first spacecraft ever launched, Sputnik. And we've been naming places on Pluto for our own use. That's why we call it informal, so that we can refer to features without having to give their latitude and longitude every time. And we're using the names, in many cases, from science fiction, from the exploration of Pluto, and from all the historic space missions that came before we could culminate the exploration of the solar system with New Horizons, because we want to honor those people and those projects. Sputnik, being the first spacecraft, got the name of this very large region. It's the left side of the heart, or Tombaugh Regio. In fact, Sputnik Planum is about the size of the state of Texas. It's hundreds and hundreds of miles across. And on all of these images I'm going to show you, there's always a little inset of Pluto in the upper right. And when you see that, let me use the laser to indicate here, there's a little box in green, so it's kind of hard to pick out on these projectors, but it shows you where on the surface of the planet we're looking. So then the main field is showing you this vast ice plain. that's made of nitrogen and carbon monoxide, but that has these interesting patterns called ovoids or polygons that may be evidence that the surface below is churning convectively due to some heat source or some differential in the density of the materials below the surface that causes that churning or convection on a very broad scale. You can see a scale bar, it's 20 miles across. So these individual ovoids are like the sizes of cities. What these little dots and hills are and what they're doing there, no one knows. This next image is made a few hundred miles to the northwest, up at the boundary between the northwest side of Sputnik Planum and the mountains that abut it. And before you get to the highlands over here, and we'll show you eventually, when it gets to the ground, we'll show you stereo imagery so that you don't have to take my word for it that they're highlands. You'll be able to see it for yourself. A region of a chaotic jumble of mountains. We believe that these are water ice because of how steep they are. And water ice actually floats in nitrogen ice. So the idea here is that somehow the water ice mountains either were undermined and tumbled, that must have been something to see, or were released from down below the nitrogen, the crust of Pluto, and floated up and formed this sort of random assemblage, of mountains spanning several hundred miles. This chaotic terrain is very reminiscent of similar terrains we see on Jupiter's icy moon called Europa. So we may be seeing some evidence of a very interesting period in Pluto's history when big parts of the surface overturned. We'll find out more shortly. This is another place, actually not very far away on Sputnik Planum, and I just want to show you that we're seeing evidence of glacial flows around obstacles like these islands in the ice, and you can actually, hopefully you're close enough to the screens to be able to see actual flow features around the steep, stronger islands. We didn't expect that either. Glaciers and moving glaciers on the surface of Pluto, not predicted. In fact, this is another example of glacial flow, but here, instead of the flow being from the plain onto the margin with the mountains, this is an example of flow out of the mountains, down through these canyons, spilled out into this bulbous region down here. All this ice has flown down these mountains and into Sputnik Planum, probably due to some climate change that took place, whether recently or long ago on the surface. And if you don't quite believe that the evidence is good for that, let me show you this next image of the same place where I put this inset. This region is that region, the circular region, delineated by the blue arrows, taken in a different kind of light from a different angle where you can actually see the flows on the surface. They're intricate. And it really proves that this stuff came down like a slurry and froze out down there. Pretty titanic. If something like that happened on the Earth, that scale, it would bury something the size of a state. Now, this is another place on Pluto, very different, up here in the northwest, in the highlands below the polar cap, where you see what we call the measles. Not really sure what those may be. Are they craters that have bright rims around them, or maybe some frost deposition, or something else? We're not sure. Are they features formed by sublimation or by impact? We have a lot of work to do to determine what that is, but you can also see stress fractures that form canyons that run very large distances, a couple of hundred miles. And if you look very carefully up here in the upper right, it's very hard to see for me on these projectors, but there's an intricate pattern of interconnected lanes we call a dendritic network. That kinds of things that we see on the surface of Mars that indicate some sort of fluid flowed through that region, or at least a very soft solid, a slush or a slurry, or maybe a fluid actually in some time when Pluto had a thicker atmosphere. Completely unexpected and very exciting to find this kind of complexity and these kinds of features that we're used to in the inner solar system, being found 3 billion miles from the sun in a place whose surface is 400 degrees below zero. Now here's another place on the surface, very different. Down in this dark region that we informally call Cthulhu. And if you're a science fiction fan, you know where that comes from. And look how complicated this is. This is an old terrain, very obviously beat up and battered, a lot of craters, right? But it has also big canyons running east to west across the region. And soon we'll be able to show you these in color. And I've already seen that data. And just to be a tease, it's mind-blowing because there are color variations even down inside the canyons. And this is just to the west of Sputnik Planum. Some of the scientists on the team think that these long channels may not be channels at all, but could be the result of stress fractures if Sputnik Planum had been formed due to a giant impact on the surface of Pluto that formed a basin in which all that ice eventually accumulated. Don't know if that's right or wrong yet, but it's an idea that's in play. Now we're going to change to Pluto's atmosphere. These are pictures that were taken just a few hours after closest approach, looking back as the sun shined through Pluto's atmosphere. On the left is the raw image that's actually the discovery of a giant haze layer, a global haze layer that's elevated as much as 150 miles above the surface. And no one really expected this. On the right is the same image, but transmitted to the Earth just a few days ago, really, a little over a week ago, without any JPEG compression, so that we don't lose any of the details. And you can see how layered the haze is. I'll show you in a few slides an even more detailed, mind-blowing image of the hazes that shows almost 20 layers in the haze. And we don't understand that at all. But I like this image a lot because it reminds me of the Earthrise pictures from Apollo 8, the first mission to send humans to the moon. And those were really iconic because it proved by seeing the Earth rise over the moon that those astronauts were really there. And the only way you can get a picture like this is to really be on the far side of Pluto. And so this is our Apollo 8 moment, if you will. This is that same picture with the discovery of the mountains, but I wanted to show you what happens when you stretch this image in the computer so that you can see finer details of what's going on over here. Can you see mountains and craters and topography on the night side? It's not because the surface is glowing. What's actually happening here is the hazes above that region on the night side are still seeing sunlight and reflecting that sunlight softly onto the surface. It must be amazing to see a sunset on Pluto with these haze layers. And we can actually see evidence of that because this haze shine allows us to map portions of Pluto that we otherwise couldn't. It's not only a scientific bonanza, but operationally it's going to allow us to do more mapping because we otherwise couldn't see on the night side. And this is one more picture where the hazes have taught us something new. You see those dark lanes in the haze? Those are the shadows of mountains, blocking light at sunset. So this is that Terminator. Now the spacecraft is on the far side looking back in detail, and those dark lanes are telling us that there's a very low-lying haze right off the deck, right off the surface. It may even be a surface fog on Pluto. That's just amazing that we find all this complexity and these Earth-like features so far from home. Well, I said before, New Horizons was in the news a lot around the time of the encounter, and it really captured people's imagination. I remember that a friend of mine in Boulder, where I'm from, said to me in the middle of June, he said, you know, at my house we take 6 magazines every month, 5 have come, and your mission is on the cover of all 5. He said, there's one more coming. Now, if you're on the cover of Cosmo, I'm going to jump off my roof. Fortunately, he's safe. But New Horizons really captured imaginations, and that's shown here in the crowd at our Mission Control Center at the Applied Physics Lab up north of here, where we had approaching 2,000 people on site. And look, it was just pandemonium. People proud of what our country can do, proud of what NASA does, excited about exploration, about seeing a new world for the first time in real time, very 21st century experience. And for 15 years, I told my team we'd make the cover of the New York Times above the fold, and there it was the next morning. Pretty good, but guess what? We made the cover of 450 newspapers the next morning, the cover above the fold, 450, a record for any NASA project, I'm told, and over 12 billion web hits in one day. The previous record was a little north of 1 billion, so 10 times higher response than the previous best NASA had ever obtained. Some of that's because we worked very hard on the New Horizons project to really interest people in exploration, the exploration of Pluto, what we were doing. But I think some of it is just Pluto. Pluto's a bit of a brand. Everybody's always known, when you were a little kid, it was always the planet in your textbook with all the question marks, the most mysterious one, the little tramped on underdog of the astronomers, right? And then it had that heart on it. And who could resist that? Well, it turns out no one. In fact, people are now out marketing it. If you go on the internet, people are selling hats and shirts and coffee mugs. They're selling, maybe the Smithsonian is, for all I know. They're selling bumper stickers and all kinds of things. And I think that just shows what a viral response it is. And I encourage you to wear Pluto, right? Show it off. Show off how much you love space exploration with something I guarantee you people will ask you about. I was flying home from Phoenix this weekend, and I was wearing my own New Horizons shirt, the same shirts that they're wearing back there. And the steward on board the airplane said, "That's New Horizons on your shirt." I said, "Yeah." He goes, "Did you work on that project?" And I said, "Yeah, I do." He goes, "I have a question for you. All those Star Trek and science fiction names, like, those are the coolest thing I've ever seen. Are they going to stick?" I said, "Well, I sure hope so. That's our plan." So just by wearing the shirt, right, people struck up a conversation. And you can do the same thing. And it's a great entree to talk about science and STEM education and the fact that this country really is on its game in the 21st century. So this is my favorite image that we have made, sent to the ground to date. It's a picture taken 15 minutes after closest approach by New Horizons, looking back from the night side of Pluto. And you can see those mountain ranges in detail. If you look on the horizon, you can see the mountains individually sticking up. Those are about 11,000, 12,000 feet high. And above it, you can count the haze layers in Pluto's atmosphere. I think this is just an enchanting image. Really, it's almost beyond words. It's almost art. I've had people tell me on social media, in person, by email, that they think that this is the picture of the decade, maybe the picture of the century. I don't know if that's the case, but it's a very powerful, moving image. It's science's art. And so I'm going to close by just saying thank you for having me to Air and Space. I'm looking forward to answering your questions. The New Horizons team is proud of what we've done. Looking forward to bringing you a lot more of Pluto and the science that comes out of it. And very proud of the fact that we could do this for all of you and make this happen, make this dream come true for the scientific community, something we could share with the public. So thank you very much, and I'd be happy to answer questions.
Thank you.
Thank you.
So you want to do this sitting down or standing up?
We can do it. Standing up sounds fine. And our project has bumper stickers. And somebody's got those, but there they are. There they are. It says, "My other vehicle explored Pluto." And then it's got the Pluto in the rearview mirror there on the left. And the fine print says, "Objects in the mirror were closer than they appear." So those are the coolest bumper stickers, I think, in the space business. We have 5 of them, so the first 5 of you to ask questions will each get a bumper sticker. Have at it. Who's first? Yes, ma'am.
Could you come to the microphone, please? Thank you.
Hi.
Hi.
I'm Alex from Poland, and I've got a question. How long do you think you will be analyzing those pictures and materials New Horizons will send?
Well, Alex asked how long we'll be analyzing the data. People are still making discoveries from Voyager data more than 25 years after the Neptune flyby. And I can guarantee you the Pluto system is every bit as complex. So it's going to be quite a while, about a year to get all the data to the ground. So some of it we won't even be able to start on until then. Yeah. And then, I foresee hundreds of scientific papers coming out of this between Pluto and all of its satellites and all the different kinds of data sets that we have.
and how many scientists, I mean, from different majors?
So how many scientists are on the team?
Yeah, and
Yeah.
they will be analyzing
We have
it.
40 on the main team called the co-investigator team. And then we have a number of young scientists, postdocs that are helping us, about another 20 or so. And then many collaborators. At the Encounter, the science team was staffed up to almost 100. But we're going to put all the data in the NASA planetary data system. So scientists from anywhere in the world, whether you worked on New Horizons or not, whether you're in the United States or not, will have access to absolutely everything. So I imagine in the end, thousands of scientists around the world will work on this data.
Amazing.
Thank you.
Great job. Thank you.
Thanks.
Okay, next we have an online question. Is that right, Marty? Yeah. Okay. Are the dynamic geological features on the surface of Pluto driven by seasonal changes or internal heat sources? It's Vince.
Vince, the answer is yes. Probably both. We know that seasonal changes take place, even from the Earth, with the crude resolution and capabilities of observing Pluto from 3 billion miles away. We were able to see that the distribution of bright and dark patches on the surface has been changing over the last 2 decades, and we could see that the atmosphere was dramatically changing. The pressure at the surface more than doubled, maybe tripled since the 1980s. So we know that volatile transport is taking place. We see in the high-resolution images all that geology and even evidence for convection cells and Sputnik planum. So it's not a question of either or, it's a question of what happened where and when. And that's what makes Pluto so complex.
Next.
Hi, my name is Shauna. I actually saw you speak at Stellafane and got one of the vintage bumper stickers from you. And I noticed one of the photos you showed of the craters where some had the dark rims and some had the brighter ejecta rays.
On Charon?
Yeah, on Charon. I noticed that some of the smaller ones seem to be the ones with the darker rims. Is it possible that maybe there's a dark layer and a light layer and the bigger impacts are excavating more, or does it seem more geographic, dark here, light there?
If what you're noticing by eye, the smaller craters and the larger craters, the ejecta blanket reflectivity correlates with the size of the crater. If that's so, then that's a very good model for what might be happening. I don't know that that's so. In fact, we have several cratering experts on our team, and they've all cautioned me that they haven't counted enough craters to be statistically important, and there are lighting effects, and some of the craters are secondaries, that is caused by ejecta from others, and you have to be very careful in this analysis. But I like your thinking. Thank you.
Thank you. Yes, sir, you're next.
Thank you. Very, very good presentation. Following on that same vein about the craters on Charon's moon, is it possible that the dark material or the change in material could be from the material that created the impact?
Yeah, it could be a contamination. That material could be a contamination from the impactor. It could also be due to the age of the crater, where bright material might turn dark over time, and we might be seeing older versus younger craters. There are a bunch of different hypotheses, and when we have all the data sets on the ground and the ability to really do the science, not just quick reaction triage, but the careful investigation with color, composition, stereotopography, all the geological imaging, all of that, I think we'll unravel this story. Thank you
very much.
Thank you. So next we have another online question. I believe. Where is New Horizons going next? How far into deep space will New Horizons go?
Perfect. I was hoping somebody would ask because I brought some slides. Yeah, so New Horizons is traveling very fast, so fast that it's escaping the solar system. It's going out into the galaxy like the Voyagers. But let me just skip ahead to the right slides. Maybe I should have put these up front. There we go. We want to go on and explore the building blocks of small planets like Pluto. These so-called Kuiper belt objects, much smaller, perhaps the size of Nix and Hydra, that contain the chemical information about the objects out of which small planets like Pluto were made, and that can tell us about how small bodies in the Kuiper belt, much smaller than a planet, evolve over time. So with NASA's permission and funding, we'll fly that mission. We already have a target in mind, and if I can put the slides up, I've got a couple more. Can we do that? Yep. So forget the words, I'll say the words, but that's a view of the Kuiper belt. The concentric circles are the orbits of the 4 giant planets, Jupiter, then Saturn, next outward Uranus and Neptune. You can see where we flew by Pluto, the red line is our trajectory, and we're going right through. We're going to transect the Kuiper belt. Now that's actually a very big structure, about 2 billion miles across. So, and we're traveling very fast. So we've actually found a Kuiper belt target. We call it potential target 1. We used to have 5 potential targets. We've selected PT1 as our choice, and we're going to be firing the engines to aim the spacecraft to rendezvous with it next month. And the actual rendezvous, the flyby, will take place, this is an easy date to remember, January 1st, 2019. So about 3 years and 3 months from right now, 1 billion miles beyond Pluto. But first, of course, we have to propose for the funding. So we'll see if NASA approves it. I hope they will, because there's lots more exploring to do. And New Horizons is healthy and full of fuel and ready to do that. Thank you for asking.
Okay, next.
Who's next?
Well, you said that the fuel that you had used half the fuel that was on board.
Right.
With half the fuel left, with only half the fuel left, how much longer will that fuel last, and what happens when it's gone?
Well, we'll never run out of fuel, probably, because it looks like we'll run out of power first. The spacecraft is powered by a nuclear battery, and the material in the battery is called plutonium, which, by the way, was named for the planet Pluto in the 1930s. And the plutonium generates less power every year because of its half-life. And eventually we'll get to a place where we may have fuel on board still, but we can't generate enough power to run the main computer and the radios. And our best estimates are that that's 20 or 25 years from now. So this flyby that's only 3 years from now is duck soup from a power standpoint. And we should be able to fly the spacecraft and keep on exploring out into the 2030s. I hope I'm able to keep exploring into the 2030s. It's a while off.
Hello. I want to ask, recently Kepler found a new, almost like Earth planet, Kepler 186f. So how long do you think until we can reach this one?
Right, so you're asking about how long until we can reach planets around other stars, like the ones that NASA's Kepler mission has been finding. And that's going to be a long time. So New Horizons is the fastest spacecraft ever launched, and to travel to the nearest star, Alpha Centauri, which, by the way, is believed to have at least 1 planet, and may have quite a number more, would take New Horizons more than 10,000 years. So even though this is very fast spacecraft, that, you know, our speed is amazing. It's New York to LA every 4 minutes, 24/7, right? That would take 10,000 years to reach the nearest star.
But we're getting much faster with the technology. If you compare it to the mission to the moon, it would be much faster. So
And you're absolutely right, and I agree. In the future, we'll probably have spacecraft that can travel many times faster than New Horizons. But even if you made it 100 times faster, which would be fantastic, it will still be a 100-year journey. So we'll have to build a very reliable spacecraft to do that. Maybe you'll be a part of that project.
hopefully. Thank you.
That'd be great.
Okay, next we have another online question. Have any previous theories about Pluto been reversed based on New Horizons findings?
Well, one is, one easy one, is that, you know, for years now, thanks to the Hubble, we've been finding more and more satellites of Pluto. We found 4 new satellites of Pluto since 2005, and the science team broadly thought that as we came on approach and got closer so that we could do better than Hubble, that we'd find more. We had a betting pool. No, I don't think anybody bet 0 more satellites, but that's what we found. Some people were betting we could find 10 or 20 or dozens. Other people were betting 2, 4, 6 more, maybe double the number. We didn't find. It's clean as a whistle. We've looked very much more sensitively than Hubble can, and yet it's a mystery why there are no more satellites there.
Great.
Thank you for asking.
And we have another one. Were you ever worried about the success of the New Horizons mission?
You bet. I worried every single day for 9.5 years. But frankly, I was more worried before the spacecraft got safely into space because, you know, we're in Washington, right? You're always at risk whenever you're on the Earth. that the project could be shut down or slowed down. I was very happy when we could get it into space where it was safe. Thank you.
Yeah, Sean.
Hi, Sean here. I work at the museum. You mentioned during your talk about comparing Pluto to features seen on Europa. Are there any other solar system analogs that you've been looking at, and say in terms of Triton?
We do see similarities to Neptune's large moon Triton, which itself used to be a planet orbiting and was since captured into orbit around Neptune. But we also see similarities to the Earth in the glacial flows. We see many similarities geomorphologically to Mars, really blowing our minds that this is another Mars. And we call it the other red planet. And to the icy satellites of some of the giant planets as well. And on our geology team, and I'm not a geologist, but the geologists, you know, they work a lot by analogy, where they're looking for examples of similar morphologies that have been modeled and understood in previous explorations from missions like Cassini and Galileo and Voyager. And we're finding many examples on Pluto and its satellites of other places, but also completely new phenomena. In fact, we're going to be releasing some images later this week of a completely unique type of terrain. It's just mind-blowing and makes my head hurt to think about how it may have formed that we see on Pluto that we don't see anywhere else in the solar system. Thanks for asking.
Okay, another online question coming up next. How many mission names, how are mission names decided? Why the name New Horizons?
We spent a long time choosing the name New Horizons. Back in 2001 when we wrote our proposal, we wanted something that would be inspiring and that no matter how you thought about it, you couldn't find a negative aspect to the name. I'll give you some examples, and I wrote an article about this, it's on our website under the PI's blog or log, about some of the other names that we thought about. And just one example was we thought about how far we were going and how this in a way represented something in completing the reconnaissance of the solar system, almost like what the Apollo 11 crew did in being the first to the moon. And so we thought about taking Neil Armstrong's phrase and calling the mission One Giant Leap. Except somebody found a negative connotation. That maybe this going to Pluto thing was one giant leap of faith. Well, we didn't want anybody thinking that, so we didn't name it that. It was named New Horizons by a vote of our science team in the spring of 2001 when we wrote our proposal. And I'm very happy with this name because we're going to New Horizons, literally, and because we created a way to explore the outer solar system on 5 times less budget than Voyager. We're also creating a programmatic kind of New Horizons, a new way to do business more affordably. And so I think the name is just perfect. Thanks for asking.
Yes, sir.
Hello, I'm Fabian. I just read in a newspaper about a golden plate on the New Horizons. Can you tell more about it?
A gold plate?
Yeah, it's a golden plate with pictures of the Earth. I don't know. I think I read it in the newspaper.
Yeah, that's on. There's a CD-ROM that's on Voyager.
Okay.
That has pictures like that. We don't have anything like that on New Horizons. We do have other mementos, and those have been, you know, there are 9 of them, and they've been discussed before. We do have a CD-ROM with the names of 500,000 people that wanted to send their names to Pluto, and a CD-ROM with messages from the team members who built the spacecraft and designed it. But nothing with pictures like that. Sorry.
Okay, thanks.
And the next online question. From the surface of Pluto, would the sky show any color?
Well, that's a good question. We will determine that. The color of the hazes will be determined because we have color imagery that includes the hazes that just came to the ground in the last few days. So those are being analyzed. And I expect that we'll be able to say something about that before very long.
Do you think Pluto will ever regain its planetary status?
Do you?
I don't know.
You know, I'm an expert in planetary science, and so are the people on my team. We're planetary scientists. And we consider these small planets to be planets just the same way as the larger planets, just the same way that a bonsai tree is really a tree because it has all the attributes of a tree, right? Pluto's small and diminutive, you know, it's not as big as the Earth, but it's got all those attributes. You know, it generates weather, it has seasons, it has 5 satellites, it has active geology, it has mountains on its surface, it has polar caps, all the attributes of planets. And I think it's widely believed among planetary scientists that the astronomers, who are fine scientists but not experts in planetary science, really stubbed their toe in their definition of a planet. Because their definition is mostly about where an object is, not what an object is. And if you actually work out the math behind that definition, it creates a steep mathematical bias for objects being planets in the outer solar system. In fact, if you took the Earth, one object I think everyone would agree is a planet, and put it anywhere in the Kuiper belt, in any orbit you choose, circular or elliptical, inclined or not, near or far, it would not be a planet by the astronomer's definition. Now that's kind of silly, the Earth not being a planet. So it's widely thought that that's a very deeply flawed definition. Unfortunately, it got a lot of press, and probably most of you think it's somehow official. Here's the good news. The astronomers don't have a police force. So in planetary science, we call things planets when they have the attributes of planets, and we just move on. You should too.
Okay. Thank you.
Okay, so we have to thank Alan once again for his marvelous achievement and for his great presentation today.
Thank you.
And I want to thank you for coming. I want to thank Boeing for its support of the What's New in Aerospace series of programs. And this program will be archived on our website so that if you want to go back and watch it again or tell anybody about it, it will be there on the National Air and Space Museum website. So thank you for coming.